Let's make sure that the stream is working properly. Maybe just taking a look at these rice fields until I get everything set up properly. At least on my end. Okay, so it sounds like I'm a little quiet. So I'm going to try projecting. If not, I'll just pump up the mic a bit, hopefully. Okay. We're going to just give it a few minutes and let people start to come in a bit. Yeah, so ooh. Okay, so it looks like I'm getting a little bit of errors, so if you guys are seeing that it's a little laggy, that makes sense. So I'm going to double check that, and I'll be right back. Okay, let's see if YouTube keeps on throwing a sad face at me for this. Okay. So I'm just going to keep messing with a few of these values until I get, until I got a good stream going. So I may have to restart it, but stick along anyway. So are you guys able to hear me right now? Or is it just the frame rate's lagging? Because I do believe that this is still having issues. The stream it is. Well, yeah, it still is. Okay, so I'm going to fix this really quick and I'll be right back. Okay, so let's see. Okay, let's see if any of the issues have been resolved. So I'm going to quickly switch to a different view to see how much the frame rate is lagging. Okay, so it's not that bad. Okay, so I'll get started in a few minutes. I just kind of want to get everybody into the same room. Okay, so magically, increasing the output resolution fixed the issue. I don't know how, but my computer or laptop isn't experiencing that many issues now, so go with whatever works. Oh, no, just as I said that, the stream, the YouTube stream health quality check came in and said that it was not doing okay. So I'm going to try and change it. And we'll see what happens there. Okay, so it still says okay. Jump into chat and let me know if it's absolutely terrible and you can't deal with it, because then I'll try and fix it some more. But if it just says okay still, we'll go with it until it starts throwing bad health at me. Actually, I just found out, so 40, maybe that might fix it. Okay, so this does not fix it. Oh, okay, so whatever. I'm gonna give it a few seconds so then I can trim all of this off at the so then no one else has to deal with this, and then I'll just get going into this. Okay, welcome to, let's start from the beginning. Okay, so welcome to Easy Intro to Linux Kernel Programming. So this is just going to be going over very briefly all of the things that you kind of need to get set up so then you can make Linux loadable kernel modules. Okay, so there's a lot of small nuances with this, so I'm not going to jump into all of them today. This is definitely a multi-session topic, but I'm going to get you started so then if you want to skip ahead and do other things with this or just try and find other cool modules to try and implement, then you'll feel slightly comfortable with at least doing your own research into it. Because Linux kernel programming is such a heavy topic, the goal here is just to make you feel more comfortable and confident diving into the subject, because it's so easy to be not confident in the subject because of the name itself. It's just so overbearing, right? Okay, so exactly what we're doing today is we'll go really quick into the setup. Since I assume that if you guys are going to be following along, you're going to be using the Kali Linux distro, and that, in order to get mine working in my VM, took quite a bit of work. So I have the exact steps to make it really easy for you guys, but it's a couple of workarounds that we have to do. So I'll go through the setup process. I'll talk about the Linux header files, basically the files that we need in order to make our loadable kernel module. And I'll explain make briefly, and then I'll dive into the code. I guess I left out the slides explaining Linux kernel modules, Linux loadable kernel modules, excuse me. So these are basically like the drivers of Linux, right? So if you wanted to have a kernel level program running, then this is how you would do it. You would load it into the kernel, and it would operate in kernel space rather than user space, right? So let's say that you had a brand new piece of hardware, right? That's like wireless communications. Let's call it like Bluetooth or something, right? So you have Bluetooth, right? And you want to like actually implement it across multiple versions of Linux, right? You want to have it properly communicate. It's a hardware level thing, right? You want to make it safe because Bluetooth should be safe, right? How you would implement it is via a Linux loadable kernel module, right? So what you can kind of get from the example from Bluetooth is just that you're able to do a lot of low-level stuff, but at the same time you can give a lot of high-level programming access to other people as well. So that's the second half of that. So providing high-level access to what you wrote is a different session entirely. We're not going to touch that, but we'll definitely go into the low-level stuff this time. Okay, so for the setup, if you're running Kali Linux, what you're going to need to do is double check your sources. So this is basically when you run an apt get update. So you try and update your repositories. It will check whatever links are in sources list. Okay, so apparently there was an issue where you couldn't immediately get and download the Linux headers. So yeah, so this is the way around it. You just put this at the top of the file, remove everything else, save a backup file of sources.list just in case it doesn't work. Okay. Then you once you have just made your new sources.list, this right here, then we're set, right? Then all you have to do is run the apt-get update and apt-get apt-get dist upgrade and soft install, so safely, so with the Y command, and reboot, and then you're finally able to use the um, the apt-get install Linux headers, and then this will just simply make a call to the root, to whatever kernel version you are. So it's Linux headers, and then that shell command to run, to just say whatever version you are, so you don't end up messing anything up. So simply, if you're running any other distros, I put the other commands for getting it. It's the exact same thing. Fairly easy. So if you guys want to be following along, let me know in chat, and we'll update it. But if you guys want me to continue on, then I will just go on. And all of these instructions will be posted afterwards on the GitHub page associated with this live stream. If you check the description right now, you can jump in and just grab the files that I've prepared for examples. Those are already uploaded, so you guys can jump ahead if you want. And otherwise, I guess we're just going to continue on. Okay, so you're probably seeing the last slide and how much effort we actually have to do to actually get Linux header files. Why do we need them? Okay, so basically, these header files allow us to actually use the kernel level functions, right? They're an interface to let us interact with the kernel itself. So we can use the kernel functions like the assembly package. You could use, we're going to be using like the init modules and stuff like that. You're able to use a lot of the functions usually reserved only for the kernel space, which is like the main advantage to what we have right now. Okay, and why do we need them? It's because we can't compile our program without them, right? And since it's on Linux itself that we're going to be programming it or trying to compile it. Oh, sorry, excuse me 1 second. Yes, please. Okay, so excuse me 1 second, guys. I'll be right back. Okay, so we're back here. Sorry for the interruption, guys. So simply, let's just go back into the presentation here, and let me try and recuperate my chain of thought. Yeah. Okay, yeah, so Linux header files, I explained that. Really, we need them to compile our program, and they're not automatically provided uh, with our with your distribution, so you're going to have to download them separately, as I explained how to do that earlier. Right? Again, if you guys are trying to follow along and you guys want the commands for updates, then let me know and I'll actually post them in the comments so you guys can follow along. Okay, so we're going to be using makefiles, but actually what we'll do right now is we'll just hop right into the demonstration, and that way we can understand what we're actually trying to do. And why we need them, okay? So on this right here, I'm going to start installing the headers. New name, then -r. Okay, so this is the -r in here. Will simply just input whatever kernel version you're running, which is perfect because we want to save some time and I don't want to deal with typos. So I'm just going to wait for these to go through. Okay, so in the meantime, I'll start showing off the code and the makefile right in here. So again, if you guys wanted to see this on your own screen, it's already in the description below. So in here is the actual makefile. So imagine whatever program that we're trying to compile, so whatever C file that we're trying to compile, this makefile gives rules to a program called make, and those rules just basically allow us to not have to worry about compiling it, right? So it takes a lot of steps off of us having to type things in, etc., etc., having long, confusing statements. It will handle a lot of the extra work behind compiling it from the command line for you. So we'll, in a second, when we actually compile it, you'll notice that when we do, it creates a whole bunch of different objects. Okay, it makes a whole bunch of different files, and over time, if you're making small edits to the file, you have to recompile it, right? So you can do things like on edit inside of this file. It will automatically recompile and spit out the new object files for the kernel to load or whatever, right? This is a very versatile way of almost like scripting, right? So imagine a very safe bash script where you don't have to worry about the exact nature of what you're trying to compile every time, right? Like this is a very general way of making sure that everything will be consistent each run, because the make program, the command line function, does all of that in the background, right? So all you have to do for it is name something makefile inside of the directory that you're in, and then just type make into the command line and you're set. Okay, so this is pretty much all we need to see of this. The only important thing is to note that you have to name the output file, excuse me, output file the same as the .c file that you've had previously. Okay, now getting into the C file. Okay. Excuse me. So essentially this is just going to be a very simple hello world for a Linux loadable kernel module, or LKM. I'm just going to call it there so then we can save our time on that. Okay, so all we do is we have a initializer module and then also a cleanup module function, right? And both of these functions are what's required for an LKM, right? So essentially, imagine trying to be the kernel itself and allow modules to be inputted, right? And having to deal with that. So they have their own little space within kernel space itself, right? So they have to have variables, right? They're going to have pointers since this is all going to be in C, right? So trying to look at that from the kernel's perspective, right? We want to have specifically a way of initializing it. So it's like, okay, on load, we're going to be doing this, right? We're going to try and do this. Okay, and if we do that, then we're going to return this value and everything's okay, right? And let's say, okay, now we're done with the onload, right? There's no loops, whatever, everything's done. I've done my job as a LKM, okay? Now I'm being unloaded, okay? The cleanup is where where you close everything, right? So you deal with any open pointers that you had, whatever, right? You safely exit yourself from the kernel, right? Because a lot of, unless you're rootkit or something absolutely vital hardware-wise, your goal isn't to have a LKM always inserted into the kernel. Okay, so on cleanup, when you exit, all of these will be called. Okay, so so ideally, this is how you treat your you treat this like you treat your main file, right? Your main function, right? So you can call other functions from inside of here. You do all of your busy work inside of the initializer module, and then you do all of the cleanup in the cleanup module, right? So for a safe exit, right? And you'll notice up here that we have the includes being the Linux module, kernel, and initializer. The initializer is so that we can call these, and kernel and module, the kernel this module header file identifies us as a module, right? And this kernel header file will allow us to access functions like printk, right? Which is not usually used from, which is not like used in the user space, right? And since we're in kernel space, we can't use user space functions, right? So we can't use printf, right? We can't print to console. So what we're going to be doing instead is printing to the kernel, and printing to kernel, right? For the sake of time, essentially it's a kernel log, right? So we're going to be printing to a kernel log with the identifier kern info, right? So since it's a log, you can state different levels of information, right? So with different levels of information, you can state, okay, I'm debugging this, I'm doing, this is a warning, this is an error, right? You can state various levels of logs, right? And then you put in your string, and it formats it correctly. You close the statement with a semicolon because this is C, and there you go. So you printed to the log. Okay, so we're gonna get, I think it's done, and it is. So what we're gonna do here is we're going to switch into my, where it's located. And remember how I was talking about make and how great it is? All I have to do is type this, and it will just completely compile the file. I don't have to worry about anything, and it creates all of these for me, right? So before it was just, as you saw in here, it was just the hello C and then the make file, right? And now with this, we were able to, with the make file, we were able to chain a bunch of commands together via an external module, right? So we're just basically telling the make files like, hey, this, where we are right now, go use your usual script for modules, right? So it took care of all the heavy work behind it, actually trying to make it. So all of these other files that you see don't really matter too much to us besides this one. Okay, so the hello.co, K-O. So that's a kernel object, and as a kernel object, you can insert it into the kernel immediately with insmod, and then hello.ko. Now let's say that you're like, okay, I don't want this in. rm remove rm mod, and then hello.ko. Now, if you remember correctly about our code, that on load and on exit, we printed a couple things to that kernel log, right? So now we're going to actually use a brand new message to actually search that. Okay, so we're going to use dmessage, and we're going to use a pipe and grep statement to isolate what we actually want. And I believe we isolated it down to, we put hello and then this in front of each of our statements. So here we go. So it worked, it entered in, and it left right here. Otherwise, if you were to just put dmessage, it's just a huge amount of stuff that I'm not sure. Okay. Well, I don't want to go too far up because I think it shows a bunch of information on IP addressing and such. So yeah. And oh yeah, and here it says it taints the kernel, right? So essentially, there's these static statements that you use before and after. Not before and after, before or inside of a kernel module stating the license, who it's using, who made it, etc., right? So you state all of these statics that that's just considered best practice because it helps identify who's actually making them. It gives you a name, right? And the license is, let's say if you set this to a private license and you have it as a kernel module, right? If it's a private license, I believe due to licensing issues, right? If you're using the Linux license, right? Whatever it's using, and you're trying to distribute a private licensed kernel module, then it violates the initial license, right? So you're not allowed to distribute it. So that's what it means by unspecified taints the kernel. Okay, so that was our basic LKM, and we're going to just talk about a bit of what we did. Okay, so the header files. So let's say you wanted to make your own kernel functions, right? Or sorry, not make your own, find your own and actually use them and create a different program that's not just a hello world. right? It's surprisingly hard to find documentation on them. There are many of them, but I guess my Googling has not been as effective as probably some of you. So if you find some good ways of finding the uh, functions and documentation on them, then please link them below, um, or let us know. Then, but until then, we're going to be. Until then, you guys can wait on my next session, which will be about finding those kernel functions, because it is a pain. So I want to give at least a few resources to people. So then, if you want to use the proc file system, right, the file system that gives process information, right? If you want to use that, then how do you find the how do you use that in a C function, right? Do you have to call the system directly? Can you use the functions used by the kernel to make the proc system, right? So all of that will come later, but essentially finding exact documentation on all of the interfaces that you can use is very hard, but there's a lot of examples of the useful ones online. So if you look at like LKM examples, you can find a lot of good material there. Okay, and then the D message, we talked about that, so I'm just going to go back up to the make files, right? So the make files, sorry, excuse me. So make files are essentially just an extension of the command make, right? And the command make is essentially the saving grace of command line compiling, right? So command line compiling, a lot of people use IDEs, especially IT people, right? So integrated environments will just do all of this work for you, right? But if you want to have more control of what you're doing and understand it better, using a make file and make it a lot easier to do it via command line, right? Because you're able to create your own what they call recipes, and through those recipes, you can state exact rules what you want to do with each file. So, like I was explaining before, on edit you update certain things, right? So it gives you the freedom of scripting almost, but with mostly compilation and unzipping files and shell commands, right? So it gives you a certain level of freedom, but also a level of safety. Where if you were making a bash file to do the same, it would just be a massive pain because you have to state so many redundant pieces of information. Whereas make files, I believe it's PHP syntax, and all you do is have to put in that make file rule list, and you're set. That's all you have to worry about. And from the IT perspective, if you guys really aren't into the programming side, I was thinking of doing a topic on explaining make and how it can be useful for the mundane aspects of depackaging files. And yeah, so like if you were downloading a gzip or something, right? Something zipped up. So perhaps something along those lines, giving you guys perspective on useful pieces of information, giving you perspective on useful aspects of the make function for IT people. If you're interested, comment below. And yeah, so that was our very brief, very simple intro to Linux kernel programming, right? It's not that hard to get started with it. This is all you had to do. To be honest, most of your time will probably go into the setup, right? But from here, you're going to be able to feel more comfortable moving forward, because a lot of this information is hidden through text walls and stuff like that. And yeah, and somehow always there seems to be an issue with trying to get header files. So if you have a different issue, feel free to contact me and I can help you out. Or if you are having issues with trying to find a specific function for a header file, please feel free to contact us, and we'll try and help you out. And yeah, so if you guys have any questions, go ahead and ask. And otherwise, I guess we'll call this a stream. Yeah. So in future, I will lead more discussions on this topic, but I wanted to have something as a small intro to actually understanding what's happening inside of it, and a quick little intro so then you feel more comfortable with actually getting started. So yeah, so I'll see you guys next time and have a great day.